Mastering fault detection. Critical system failures are draining our business of time, money, and reputation. Why do our operations experience certain types of faults with greater frequency, and what specific impact do these faults have on our business outcomes and goals? The pursuit of operational excellence. It's a quest that has consumed me for decades, and one that has led me to dig deep into the complexities of fault detection. Let me tell you, it's a tale of triumph and tribulation, of breakthroughs and setbacks, and of the unwavering dedication required to achieve true mastery. I recall a particularly humbling experience at a manufacturing plant in the Midwest. The company, a stalwart in its industry, was grappling with an alarming frequency of equipment failures. The production line would grind to a halt for hours, sometimes even days, as maintenance teams scrambled to identify and rectify the problem. The financial toll was staggering, with losses running into millions. But what really caught my attention was the impact on morale, the sense of defeat that permeated the entire organization. As I delved deeper into the issue, I discovered a pattern that would change my perspective on fault detection forever. It wasn't about the machines, it was about the people. The maintenance teams, though well-intentioned, were stuck in a reactive mindset. They were responding to problems, rather than anticipating them. The organization was so focused on meeting production targets, that it had neglected the importance of proactive maintenance. I realized that the key to operational excellence lay in instilling a culture of proactive fault detection. This meant empowering the maintenance teams to take ownership of their work, to think creatively, and to be accountable for the performance of the equipment. It meant shifting the focus from reaction to prevention, from fixing problems to predicting and preventing them. But how do you achieve this seismic shift in mindset? The answer lay in creating an environment that fostered intrinsic drive, encouraged original thinking, and rewarded adaptability. First, we had to redefine the role of the maintenance team. We gave them the autonomy to make decisions, to experiment, and to innovate. We encouraged them to collaborate with production teams, to share knowledge, and to learn from each other's experiences. We created an atmosphere of healthy competition, where individuals were recognized and rewarded for their contributions to the organization's overall performance. Next, we had to equip the teams with the tools and training necessary to succeed. We invested heavily in advanced analytics, machine learning, and IoT sensors that could detect even the slightest anomalies in equipment performance. We developed customized training programs that emphasized creative problem-solving, critical thinking, and effective communication. The results were nothing short of remarkable. Equipment downtime plummeted by over 70%, production efficiency soared, and maintenance costs decreased dramatically. But more importantly, the maintenance teams had transformed from reactive firefighters to proactive problem solvers. They had become the unsung heroes of the organization, driving innovation and improvement with every passing day. As I looked around the plant, I felt an overwhelming sense of pride and accomplishment. The teams had achieved something truly remarkable. They had broken free from the shackles of reactive maintenance and had become masters of their own destiny. In the end, the pursuit of operational excellence is not about systems or processes, it's about people. It's about creating an environment that inspires, empowers, and motivates individuals to strive for greatness. It's about recognizing that the true secret to success lies not in avoiding faults, but in detecting them before they occur, and in doing so, unlocking a world of limitless possibilities. In the realm of operational excellence, fault detection plays a critical role in identifying and mitigating the occurrence of faults that can have a significant impact on business outcomes and goals. To address the issue of frequent fault occurrences, it is essential to understand the underlying causes and effects of these faults. Faults can be categorized into different types, including equipment failures, process deviations, and human errors. Each type of fault has its unique characteristics, consequences, and root causes. For instance, equipment failures can be attributed to wear and tear, inadequate maintenance, or design flaws. Process deviations, on the other hand, can result from inadequate training, poorly designed procedures, or changes in operating conditions. Human errors can be caused by a range of factors, including fatigue, distraction, or inadequate training. The frequency of fault occurrences can be influenced by various factors, such as the age and condition of equipment, the complexity of processes, and the level of operator training and expertise. Additionally, the operational environment, including factors such as temperature, humidity, and vibration, can also contribute to the likelihood of faults. The impact of faults on business outcomes and goals can be far-reaching and devastating. Faults can result in production downtime, reduced quality, and increased costs. In some cases, faults can even lead to safety risks, environmental hazards, and damage to equipment and infrastructure. Moreover, faults can have a negative impact on customer satisfaction, leading to loss of business and reputational damage. To mitigate the effects of faults and achieve operational excellence, it is essential to implement a robust fault detection strategy. This strategy should involve a combination of advanced analytical techniques, such as predictive analytics and machine learning, as well as traditional methods, such as root cause analysis and failure mode and effects analysis, FMEA. Predictive analytics can be used to identify patterns and anomalies in equipment performance, process operation, and operator behavior, allowing for the early detection of potential faults. Machine learning algorithms can be trained on historical data to identify trends and correlations that may indicate an increased likelihood of faults. These techniques can be used to predict when and where faults are likely to occur, enabling proactive maintenance and corrective action. Root cause analysis is a systematic approach to identifying the underlying causes of faults. This involves a thorough examination of the sequence of events leading up to the fault, as well as the contributing factors, such as equipment design, process conditions, and operator behavior. By identifying the root causes of faults, organizations can implement targeted interventions to prevent similar faults from occurring in the future. FMEA is a proactive approach to identifying potential faults and evaluating their impact on business outcomes and goals. This involves a systematic analysis of equipment and processes to identify potential failure modes, their effects on the business, and the likelihood of occurrence. By identifying potential faults and evaluating their impact, organizations can prioritize their mitigation efforts and implement targeted interventions to prevent faults from occurring. In addition to these analytical techniques,